Good evening, heroes and heroines, and welcome to Practising Programming in C. Apologies for the slight delay. I had given myself a deadline to complete a task before going live, so kind of fortunately the deadline was a movable feast, which was kind of handy, but it meant that the stream had to go a bit late, start a bit late. Let's see what's happening here. Insobot has seen that I've gone live with the title Practising Programming in C 047 PPIC Lessons 2 Structs by Insofaras. So this is awesome, right? Last time on the stream, I believe I was finishing off the compression utility, the compression test utility, after having done Insofaras' Practising Programming in C lessons 1 on strings, and then I took a couple of weeks off, kind of unscheduled, but I took them off. I did actually do some programming during that time, just trying to do like a converter for the old annotation format into the new format, which coincidentally Insofaras himself is also in that time he's like written a parser to like parse all this stuff, which is just totally amazing. So yeah, I mean, the idea is that I'll be able to, if I can convert the old stuff into the new, then Insofaras' parser can actually parse all of the handmade hero stuff, and we can get that into the new system. But let's have a look at what we're doing today. It is PPIC Lessons by Insofaras. And I have already pulled this. Is there an update to the explanation itself? I don't think there's an update. So it was all in the lessons and the solutions in the test harness. Yeah, so you can see like they're like arranged into directories now. Well, as I say, I've already pulled it. But before we can get into this, I also need to actually install something else. I've got 4Coder. Got the newest thing to 4Coder. What's going on here? Is that? Why is that still lit? That's interesting. Is that just because that's the forward thing, maybe? Interesting that this is still in my history as well. But anyway, let me see if I can get 4Codes. Where's 4Code? 4Code is here. And I've sorted by time. I believe this is the newest one. So that's gone up here, I believe. Right. I'll just see out all this, because 4Coder is alias to that at the moment. So I really need to change the alias, don't I? I need to change it to point to this guy. So this guy is at 4Coder. That's right. I could do it to the right. What's all? Oh, it's the it's in the path. Oh, I see. Right, gotcha. Interesting. What's that? Oh, I've got that as well, have I? That's weird. So that path is for 3.4.2. Maybe that path just doesn't work. I don't know. But let's just change. This is going to be delete forward to there. And it's going to be forehead. Right. That's correct. Alright, cool. So that is 4.0.17. Right, so now what I also need to do is, I don't need that anymore. I also need to get the one build system into here. So that means that I need to do vim on one forecoder. What does this actually do? Forecoder default include. Okay, so it's forecoder. Default include.cvb, okay. And I'm changing execute standard build search. Right. Oh wow, is it not even in it? Execute standard build search. Oh no. God. Where's build? Is there a build? Build command. Oh right. Oh interesting, build commands. So let's say forecoder. Forecoder build commands to CVB. Is execute standard build search in here now? It is. Wow, okay. If define Linux, build search rule for Linux. So this is still looking just for a build SSH and make file. Whereas this thing invokes this current file. Right, let's just see. This might go horribly wrong. But let's just see what happens. It should just be that, I believe. And then I need to come down here. Do that. Come out of here. And I need to run build super, don't I? Okay, so that seemed to go alright. Yeah. I see lessons. So it's structs that I want. And forecoder. Oh, interesting. It's starting up with like a different font. And it's kind of bigger as well, isn't it? I think. Let's have a look at the features actually. Welcome to Alpha 4.0.17 Super. If you're new to forecoder, there's some tutorials at this website. Newest features: new support for extended ASCII input. Extended ASCII encoded in buffers as UTF-8. The custom layer now has a markers API for tracking buffer positions. Interesting. So this is what Alan was talking about on his stream the other day. He was talking about the markers. But I think he also mentioned in his Patreon message that I don't think it exposes all of the marker stuff yet. I don't think. Could be wrong. So tracking buffer positions across changes. Okay. I don't think I had. What was I on before? Oh, I've deleted the alias, haven't I? So the most recent one was 13. Okay. So I've got a few more things to explore here. So let's go in order. New in Alpha 4.0.14. Option to have wrap widths automatically adjust based on average view width. Option to have wrap width. Okay. Right, okay. The config.4coder file can now be placed with a 4head executable file. Ah, config, okay. New options in config.4 specify the font and colour theme. Right, okay, I might want to change that. New built-in project configuration system. New unsafe hooks allows custom behaviour in the custom layer whenever a file is saved. That's cool. So maybe you can get it to build when you save. Or maybe get it to like output like most recently modified. You know, last modified date. You know, put that in the header or something. That could be a cool thing to do. When using code wrapping, any saved file is automatically indented in the text format. This option can be turned off in config.4coder. Okay. Oh wow. Control I, find all functions in the current buffer and list them in a jump buffer. Well, this sounds a bit code intelligence-y to me. Find all functions. Option to set username in config.4coder. Username's using... Oh right, Alt-C and Alt-Y comment writing commands. Okay. I think I might have to have a look at this config.4coder. That's kind of an interesting file. Let's go up to the 4.0.16. Alt-2, if the current file is a C++ code file, this opens the matching header. Okay, right. If the current file is a C++ header, this opens the matching code file. Option to automatically save changes on build in the config file. Oh, right, okay. This works for builds triggered by Alt-M. Option in project files to have certain fg commands save changes. Option in project files to have certain fg commands. Okay. Where's the easiest way to see this 4coder.config file? Config.4coder. Okay. Enable code wrapping true. Automatically does wrapping true. Default wrap with 672. That's quite a large width, isn't it? Like, how many characters do I even have on this screen? Well, it's about 160 something, isn't it? Yeah, like 166. But, I mean, that isn't actually 4coder width, is it? '73. Might just leave that. What can I indent text on? Just save. This only applies to code files in code wrapping mode. Plain text in code files without virtual whitespace, whatever. Effective, okay. I'll tell you what. Let's just change this, right, to inconsolata. Pretty sure that's the name of the actual font. Yeah. And the username, let's change that to Midlow. Triggers code CPP. It's nice how it's just delimited by the dot. So I guess I need to restart to get the actual... Oh, it might be a pixel. Oh, okay. That'd make more sense, actually. So there we go, it's taken up in Consolata. And what was it? Was it Alt T and not Y? So I'm in the Scratch, aren't I? So, tell you what, let's open up Structs.1, Structs1.c. Wow, I like how there's like an _1 promising like more structs. This is the first time I've seen this this file, which is very exciting. What? This is slightly different. So you're specifying C. I don't think we specified C99 before. Exit. End it. Okay. Standard def.h. Alright. Hang on a minute, let's just test that pixels theory. Because this width is 1168. And what was Alan saying? He was saying 672. 672 is like that. But it also adjusts by the width, doesn't it? I think he said. Yeah, options to have wrap widths automatically just based on average view width. Yeah, that's an option, isn't it? Yeah, automated just wrapping. Okay, that's possibly what's going on there. Just before we do anything more, oh yeah, it's the Alt T dot Y. So fine, that hasn't that hasn't done anything. Default name. Do I have to do it in main, I wonder? Because since I've set the name, I'd expect it to pop up as like that. What does it say? The username is used in Alt T. Yeah, right. Options set username and config dot. We'll go to username is used in Alt T and Alt Y. Comment only given. Okay. It just doesn't seem to do that. But it's definitely picked up the config because this is definitely in Consolata. Oh yeah, Control I is also... Yeah, let's just see Control I as well. Control capital I. Interesting. This is declarations in main. List them in a jump buffer. Oh, that's nice. I don't know how to switch back using the keyboard. Find and update Karma. Wow. Oh, I see. So yeah, it is listed by their appearance in the file. Oh God, exercise 2 already is a linked list. Blimey. All right, let's let's give this a go. Structs.1. Let's throw the messages over here. Exercise 1 is quite long. Let's jump back to the beginning. Build it. Right, so it has built. I don't need to be there. We need to wrap these comments better. Control that to change our focus. Control minus, isn't it? Oh, is it control comma? Oh, I'm not focused. Right, control comma. Control comma while you're focused is how to change the panel focus. Okay, so let's see if we've got a file. Lesson Structs, yeah. Wonder what this looks like. Testing update card, test failed. Yeah, I think I shouldn't look at the test part of it until I've actually read the exercise. Before I read the exercise, I am just gonna throw some music on. Partly so I can actually hear if the audio still works, basically. Mirror Moon. What we're doing again? We're doing Structs, aren't we? Teach yourself finish. Why is that popping up in Struct? Oh, instructional genre. Okay. Bridge constructor. Yeah, that could be. That could be alright. Oh, it's just like 3 tracks. Okay. I can't play Portal 2 because that kills my copyright thing. I think that'll apply to everything else. So yeah, Mirror Moon, wasn't it? That should give me a good bit of time. 1 hour and 22. So we might be here until 2 o'clock in the morning. Alright. So, exercise 1, accessing struct fields. Background. A struct in C is a collection of variables bundled together, where each item has its own name. Each of these items is sometimes called a field or member of the struct. When you have a plain struct, you access fields using the dot operator. For example, struct A, my struct.field equals 1. Okay. Right, yeah, so this is if you haven't actually type defed it. This is if you've done like struct. Well, I'll keep going. When you have a pointer to a struct, you access fields using the arrow. Oh, right, okay, that's when you use the arrow operator. For example, struct A pointed to my struct is equal to something. My struct arrow field equals 1. So when you pass a pointer, when you do like struct A star my struct, that's kind of like doing an array of structs, I'd imagine, isn't it? An array of A structs. Kind of. Could that be right? I don't know if that could be right, actually. Exercise. In the update karma function below, you are passed instances of 2 structs. Struct user and struct karma change. You must update the given user's karma according to the type and value fields given in the karma chain variable. This auto width stuff is throwing me off a bit. Can you toggle that? I don't know. Anyway. Given the karma chain, the type field will be either karma. You must update the given user's karma according to the type and value fields given in the karma change variable. The type field will either be karma increase or karma decrease, which indicate you should add to or subtract from the user's total karma respectively. Additional info. As for any other type, when a struct is passed by value, its value stream must push some key to around. Okay. Which indicate you should add or subtract. Yeah. Should you pass by value to a function? As with any other type, when a struct is passed by value to a function, changes made to this variable will be local to the function and not reflected back to the call site of the function. Passing a pointer to the address of the variable is a way to overcome this. Right. Awesome. Data types. So here's our user. It contains an int ID and an int total karma. Got an enum, which is karma decrease and karma increase. And a struct, which is karma change, which has an int type and an int value. So the type is going to be karma decrease or karma increase, and the value is going to be by however much. Function to implement. God damn it, this is it. Update karma. So, wow. So passed a pointer to the struct user. And we are past the struct karma change. We're being past one of each. There's nothing to loop over. So I think all this is teaching me here is how to access stuff from the struct, isn't it? Past instances of two structs, struct user and struct karma change. You must update the given user's karma according to the type and value fields given in the karma change variable. The type field will either be karma increase or karma decrease, in which case you should add to or subtract from the user's total karma respectively. Passing a pointer to the address of the variable is a way to go. Right, okay. So, and that is being done for me, isn't it? Because I'm being passed this, and the user contains the total karma. I see. Interesting. So I'm basically ifing on the what's ID got to do with it, I wonder? The given user's karma. I mean, I'm not going to have to touch the oh, hang on a minute, I'm getting the user here, aren't I? So it's for, well, it's not for, is it? It's like user. Sorry, no, I'm not good. It's the ID. Let's just try something. Well, actually, let's switch. Let's switch on the karma change type. Destructive we use later with the ID. Don't need to exercise one. Ah, right. Gotcha. Now I'm not very well versed in switches, so this might get badly. But I believe the way to access this karma change dot type. Right. So if it's karma decrease, I might be getting this completely wrong, by the way. Why, what, that doesn't look at all correct. Just need to wrap it like that, maybe. See if this compiles. Okay, it does compile. Karma increase. Why is it not indenting that? I would have thought that would be indenting it. I don't know. Anyway, if it's karma decrease, then what we do is we want to say that the user total karma should be minus equals the karma change dot value. Otherwise it should be plus equals. Right. I passed it. Wow. Alright, that's awesome. Sounds nice to know that I understood what was going on there. Find and update karma. Oh, this is going to be a for loop, isn't it? Right, yeah, linked lists. Blimey. Did you realise that that was that actually worked on the first attempt? I suppose technically, actually, I did compile it like a couple of times to check that I'd done the switch statement correctly. But I don't think there was any, there's no Kate Bush involved, so there was no, I don't think there's an opportunity for a Kate Bush special surprise. As far as I know. Because it just tests, yeah. Sorry, it tests, it just passes, yeah. So there's no mention of Kate Bush. So here we go, linked list. Let's just see how... Wow, that's all it is. Okay. A linked list in C allows multiple instances of a struct to be connected with pointers so that a list of entries is formed and can be iterated through. Linked lists support the addition and removal of individual entries at runtime. Unlike a standard C array, they have no fixed maximum entry counts. However, looking up an entry requires a linear time scan through the list as opposed to a constant time array index. Interesting. They are implemented by having a struct store a next pointer to another struct at the same time. See the user underscore LL struct below for an example. ID total comma user LL. Next. Pointer to next. In the find and update comma function below, you are passed the head of linked list of type user underscore LL. Head refers to the first element of the list. Each successive entry of the list can be accessed via the next field of this struct, and the next field of that struct, and so on. The final entry of the list will have a null pointer as its next field to signify the end of the list. Interesting. You are additionally passed an ID which will correspond to the ID of at most one entry in the list. Iterate through the linked list and find this entry if it exists. If it was found, then, as with the previous exercise, update the total comma based on the fields of the comma chain struct. Additionally, for both structs using this exercise make use of type def. This allows the omission of the struct keyword. Yeah, okay. We're defining the structs. In C++, the struct keyword can always be omitted. Okay, so I'm iterating through this until the pointer next is null. Well, hang on a minute. I'm going to be past. I'm past the head of the linked list. The list can be accessed by the next field of this struct and the next field of that struct and so on. No points of it. First, to iterate through the linked list and find this entry if it exists. If it was found, then it was the preset of it. Right. So list head. Go to list head. That points to well, hang on a minute, what does next point to again, sorry? Each successive entry after the list can be accessed by the next field of this struct. The head first this one to the list. Ah, hang on a minute. Yeah, if it finds it, then it can do the change. Otherwise, it somehow increments the well, it somehow follows next, I think. Ah, hang on a minute. If list head next, oh wait, no, that can't be right. The head. Head refers to the first element of the list. You're past the head of linked lists. This is the first element. Okay. So I'm past the first element of it. Each of sections of entry of the list can be accessed by the next suite of list structs. Okay. I mean, I feel like this is kind of correct, and that I won't need to iterate anything, because this, when it goes through the loop, if I'm understanding it correctly, like the next thing it'll just keep automatically incrementing, maybe. Could be completely way off there though. What was it? It was if list head ID, if that equals the ID that's passed in, then we switch on the thing, don't we? I might as well write it out again. Switch on the... Oh, hang on a minute, karma change. Is it the same? It's the same struct, isn't it? Is it? Yeah, type and value. Yeah, so it's if we switch on the karma change type. So it's if karma increase, then we do this stuff and break. Otherwise, if it's karma decrease, then we do this stuff and break. Set out karma. Plus equals the karma change value, is it? Karma change value, yeah. And break. If it, yeah. Oh, hang on a second. I need to be returning this, don't I? Let me pass that. Yeah, if that, then I need to break out of the while, don't I? Oh, mind you, maybe it wouldn't matter to just keep going. It said next. What am I missing out on here? ID. So I've got the ID. So I'm checking the ID with the ID that I'm passing it in. I'm using this next. I'm using it like this because it's being passed in as a pointer to it. But I'm referring to this guy with the dot because it's not being passed in. By pointer, it's being passed in by value. Let's see if this builds first of all. It doesn't build. Oh, that was a shame. So I failed it. Interesting. So, right. Failed this here. While list head. So the list was like that. That was the list that was passed in. And I just returned the list, didn't I? It's an infinite loop. Right. Yeah. But, right, yeah. I mean, that would make it not infinite, wouldn't it? I think list and C allows multiple instances which we could be pointers, so that a list of entries and forms we could be iterated through. Yeah, I thought there would need to be some iteration going on. Linked lists support the addition and removal of individual entries at runtime. They are implemented by having a struct store a next pointer to another struct of the same type. A next pointer to another struct of the same type. Each successive entry of the list can be accessed via the next field of this struct. Header link list of type user allow. List head is entry 0, list head next is entry 1. Ah. Interesting, okay. Ah, past it. Okay, that's interesting. Let me just see if I can understand that from the thing. So, using next. So I think the I think the thing I learned here is that you can refer to the entire struct. You know, because this is referring to the whole struct. The whole struct that's called list head. And the next is going to be pointing to the next one. How do you know that that is going to be the next one though? I just realised it's a pointer. Ah, right. I see. Oh, hang on, is it because... No, it's not because this is the last element of this one, is it? This is a pointer. Why do you do a struct? And I'm doing that next. I mean, basically what I'm kind of wondering here is... I mean, what is it that determines that this is the next pointer? So, like if I were to do, for example, this. If I were to do this, would the next thing still work? For one, well... The element very specifically through that pointer. The next exercise touches on the creation. Ah, okay, right, awesome. Let's go to the next exercise then. It's interesting that straight fucking crash there. Why did that crash? Oh, it's past. Oh, it's crashing the next exercise. Right. Okay. It's because Tesseract cuts the links. Oh, I see. Right. Gotcha. Added to the end of a linked list. How many are there in this? It's 4 exercises. What time is it? 1 o'clock. Music's paused. How long have I got? 49 minutes. I mean, surely I can't complete this entire exercise, this entire lesson, in the one stream, can I? Exercise 3. I think, you see, that was where I wasn't quite grokking what was going on there, because like you say, the test owners had created the links. I was like, well, like, what's so special about next, basically? In order to add to the end of a linked list, the final entry must be iterated to. The final entry... Okay, the final entry in the list must be iterated to. And its next pointer updated to point to the new entry. An exception is an empty linked list represented as a null head pointer. In this case, the head itself should be changed to be the new entry. Yeah. Exercise. Add the new entry, new users, to the end of the linked list. That begins at list head. And return the list head pointer. If list head is null, then the list is currently empty. The list head you return should reflect that new user has been added. Okay. Additional info. With an advanced understanding of pointers, it is possible to complete this exercise using only a single loop and no if statements. You could try this as a bonus exercise. So that's it. So I'm supposed to be iterating through the list. Hang on a minute. What am I supposed to be doing again? Add the new entry new user to the end of the linked list. That begins at list head. And return the list head pointer. So it's still user LL. It's pointed to list head. And it's a pointer to new user. List head is not. Just have a look at the test info. New user 163 and 593. So the user underscore LL. What was oh, I can't. It's not a .h, is it? I was say, what was the key to toggle between this file and the .h one? Returns a user.ll. It takes two user.lls. And a user LL is one of these guys. ID. So it's the ID and the total karma. List head. That begins at list head. which end of the step pointer. So user.ll contains an ID and the total karma. I don't need to bother with the total karma, I don't think. It's just the ID. So this new user is going to come in with the ID 163. And I should be, yeah, right. I should just be putting that guy onto there. So that means that I need to iterate to here and then set this guy's next pointer. So he needs to point to a new struct. So basically, yeah, I need to iterate until we're null, and then I want to sort of a single loop and no if statements. And it also needs to point to the head of the new user, doesn't it? I think. Oh, sorry, no, that's not right at all. It just needs to point to the struct itself. So it's like I need to be doing at some point. I need to be doing list head next is going to be equal to new user, right? I think. Let's head is entry 0. Let's head next entry 1. Let's head next entry 2. We're setting up the other guys. Oh, hang on, the test harness creates the links. So that means that I need to create the link, doesn't it? Somehow. And I also need to be saying, well, hang on a minute. Saying they need to create the link. In order to add to the end of a linked list, which is what I want to do, the final entry must be iterated to, and its next pointer updated to point to the new entry. Right, okay. And this, I mean, the struct does contain the next, right? So its next pointer must point to the next entry. I want it to point to new user. So that's what I'm saying, like, sure it's not this, is it? Oh, hang on a second. Oh, actually, yeah, is it just this, actually? Yeah, right. I think this might be correct. But it's actually, because this is going to iterate through there. Until it's not, actually no it's not. I need to actually iterate through, don't I? Obviously. And then what I want to do is, at this point, this is going to be null. So I actually want to index the one previously. I want to say that his next pointer is equal to new user. Okay. Let's just see what this does at all. This might just totally die. Yeah. That's probably because I'm accessing the wrong guy. Address not known. Because this is going to be not valid now. Doesn't go like if I raise the structure linked list don't have doesn't get it. Oh right. Okay. I suppose there's no way of going back now, is there? Like, This is going to completely be bonkers, but it's not going to be like this, is it? And then set his next. No, I don't think this is going to work, because this is just going to... It's just going to point to the same guy. And also, I'm sort of... I think I'm a bit... kind of... I'm trying to do the old bonus... the bonus exercise. And I don't have that advanced understanding of pointers. So that probably suggests to me that I need to be doing an if. But I suppose the question still remains though, like... How do I... There's no way of going back. Suppose limit so both the previous and next points. Called doubly linked. Ah, right. It's a doubly linked list, right. So there's no way of going back. I do want to get to the final... I want to get to the final one before the one that's null. So this test can't be correct. Oh, hang on a second. Right. Well, this is not null. Then what I can do is... I can do that. Okay. Failed it. But at least it didn't crash. So why did I fail? So right, I didn't return the entire list. Why didn't I return the entire list? Oh, hang on. Well, I mean, I'm supposedly returning the right thing. Oh, hang on a second. Am I losing track of the list head here, I wonder? Might be time to step through this actually. Because the list is currently like this. I want to get myself into a situation where the next pointer of one of these is null, and at that point I hop out of the loop, and then I want to set this next pointer to point to this head, or rather to point to this struct. Which I seem to be doing here, I think. You know, because I've got this outputting, and then this guy. But the trouble is I should be outputting the whole lot from the beginning of the list. And I'm not doing any I'm not getting any advanced understanding of pointers here. Remove user. So, gosh, how do I do this now, I wonder? So that is currently at that location. And the head is, sorry, the next is pointing to this location. Just double check that. Yeah. Yeah, that's the thing, isn't it? I'm setting the list head to be equal to this, so it stands to reason that I'm going through this list, just kind of losing track of the start of it. So then by the time I get down to the bottom here, I'll have iterated through, losing track of the guys before, and then I've got the one list head, and I'm setting the next pointer to point to the new user, and that gives me the 2. So that's kind of interesting. I suppose it's worth continuing. To actually verify that. Right. So the list head started off at this location. How would I keep track of it? Ah, yeah, I mean, I suppose you could store it in a temporary variable, couldn't you? I mean, so I want it to be the address of it. Unless you actually do a new struct. You know, like if you set up like star Could this be the right syntax now? Let's just try it. It's not the address of that. And also, this isn't actually that, is it? It should be. Shouldn't it be that? No. Because it's not the value. It's not the value of that struct that I want. It is the. It's the address of it. It's an invalid initializer. What was this saying? This was saying it's an invalid initializer. But that passed it. That doesn't feel right at all though. I'm not sure this is correct. What was that even doing? List head is equal to the list head next. Oh, hang on a second. Unless I leave list head where it was. That can't be right, can it? I was going to say leave list head where it was and iterate through start. And then we just return list head at the end. That cannot be correct, can it? Yeah, that ain't, that's not all correct. Hmm. So this is where I started. And this was the thing where I was returning the two things, wasn't it? Yeah. Should pay close attention to types. So okay, so user LL. An int and int. And a struct, which is of type user LL. And it's a pointer to the next. Oh, hang on a minute. Keeping track of it. So start of the list, what type of variable should be used? I mean, I was thinking it would be just an int to store literally the address. It's not actually an int, is it, I suppose? Yeah, it's not, you know, it's like a hex value is what it wants to be. We just need to copy what we're given. Okay, right, so it should be the same, type, shouldn't it? So being passed a pointer to a user.ll, user underscore ll. So it's basically like a user underscore ll. That is what we want to be. That is the type of what we want to be storing. We want to say that that is equal to just the list head, isn't it? So that's just the new user. Right. And then we want to say that the list head should then, the pointer to the list head should then equal the start. Is that going to, no. But hang on a minute, wasn't this what I did? And then didn't it just infinite loop on me? Pointillist is not the same type as start. Right, yeah. Because a pointer to list head would be like, it'd be like saying there's 2 pointers, 2 asterisks, because it already has an asterisk on it. So I'm still getting the same thing here. Gone through, we have set next to equal to the new user. So we have made that list. Sorry, we made the link. I presume correctly. But then I just need to make sure that I set the list head to be back to the start. Oh, hang on a minute. There's only one problem. Ah, okay. Uh, so if it was empty, then the list is going to, if the list is null, the list head you return to reflect that no user has been added. Ah, right. So Structs list head. If list head is null. So if it's null, then we're not going to really enter this loop. Oh, hang on a second. Do we just check this? Why is that failing? Oh yeah, of course, because like, not necessarily. So I didn't get any output. Let me just see what. Let me just step through this actually. I presume I'm hitting the case where it is null. Let's continue until I crashed. I haven't crashed yet. The list head here is null. Right. So what should happen here is that start is going to be set to null. Oh, right. Yeah. Which isn't correct. So the condition was that. So I wonder if I have to do it in a for loop. Could that be correct? Because it's going to first of all test this condition. It's going to, well, hopefully it'll test this condition before setting the thing. Or maybe it won't. What I'm basically saying is, the easy way is to branch on list head being null. Well, hang on, if list head even exists here, then we go in. Otherwise we just set this. Yeah, it's not next, it's list head. Just list head. Oh shit, I passed it. So that's interesting. So there's my if. Only single loop and no if statements. The easy way would be to branch on list head being null. Call back to add the bonus later. I think that's what I'll have to do. Should I have a glance at the next episode? Removing from the linked list. It's written at this beginning at list head. Follow entry with an ID. Best user free. Okay. So, why is the music stopped? Is it at the end of the playlist? It's not at the end of the playlist. 19 minutes. Bog user free was not called. Okay. How do you like that? Oh. Scored on that, expected that. Actually, the linked list, we're going to list after entering an ID. Back to give an ID. So iterate the linked list. Let's give it a go. Let's see what happens. It needs to handle the null case as well. So I didn't get the bug, which is fortunate, just failed the test. So I did remove the guy, didn't I? Oh wait, I outputted nothing. Oh sorry, yeah. So I need to have kept the guy around, shouldn't I? What was it? Else. Study the start. So this time I did output the entire thing, but I just hadn't removed the thing. Oh right. Ah, hang on a second. Of course. Well, wait a second. User free. What does that mean to do? Remove this entry and pass it to the user free function. Okay, fine. So basically, I want to say if this matches the ID, then I want to Oh, well, I need the previous guy, don't I? I want to make the previous guy point to this guy's next one. Right. That's probably what's going on here, isn't it? you probably have to you probably have to make a new struct. Right. Then what you do is you say prev the prev's next is going to be equal to the list heads next. And then down here what's different down here? Just give the same output. The list head should equal to the list. Yeah, but that's not quite correct, is it? Because the list is just set to this at this point. I'm going to have this, I'm going to have a linked list. I need to go through the list until I find a matching index, which is here. Now the matching index I need to remove. List head. List head is the struct that I'm being passed in. What have I said next? I mean, this won't make a difference, I don't think. Because I'm not setting the thing back to the right value. Maybe you've got to do something like kind of build a different list. Two times a day longer. I think I'm too tired to stay longer as well, actually. So I might call it. I'll call it and come back to it tomorrow. Have a good night's rest, and thank you so much for the lesson. Yeah, with a bit of luck, we'll resume tomorrow. Yeah, that's what we'll do. We'll call it here and come back tomorrow. So yeah, thanks for tuning in. Thanks, insofaras in particular, for doing the lesson. If you fancy doing the lesson yourself, you can find it at this location here. So I'll just throw that into here, and also, can I see if there's, I don't know if anybody's down here, but here as well. If you fancy doing the lessons. But yep, until tomorrow, farewell for now.